Hey guys, in last video we saw how to set up assembly script, understand array buffer, and load WASM file into web applications. In this video we'll be taking a look at what happens under the hood during the compilation and instantiation process. We will also be discussing about exports, imports, and custom sections. Let's start now. So in last video we used WebAssembly.compile to compile the bytes that we received into a WebAssembly module object, but we don't necessarily need to compile it using the compile method. Let's see how compile method works internally. Let's see it's working under the hood. So basically compilation process follow these steps. It validates the bytes that we just received. If validation is true, it constructs a new WebAssembly module using those bytes. So let's do it manually. So I'll create a new object called compile WASM manually, and WebAssembly namespace has given us a validate method. It has given us a validate method where we can provide the bytes to it. So I'll simply provide buffer, and if it is not valid, I'll throw a new WebAssembly.compile error. This has also been provided to us by WebAssembly. So I'll say invalid bytes. So once the validation is complete, we can simply create a new WebAssembly module object. So module new WebAssembly.module, and then we can pass in the bytes here, and we can return the module. We can also see what it exports, imports, and what are its custom sections. Let me console log these. So we have imports and WebAssembly.module.imports. We need to provide the module. So we created a module instance and we are providing a module to find out its imports, and in similar way we can extract exports and custom sections as well. Exports, custom section. So custom section, you need to provide a module and also the name of the section. We'll be taking a look at all these three things, but let's see what happens now. So I also need to replace this. I'll do module 2 and I'll pass in module 2 here, and we can compare it manually. So yep, so we received the buffer. This is the module that we get using WebAssembly.compile statement. So it has all this stuff: prototype, exports, imports, nothing. And this is what we get if we do it manually. So we have module here, exports here, and imports as well. So both these modules are same, and we are instantiating module 2 now, and we got the instance as well where we can call in the add method. So this is how compilation works under the hood. Validate the bytes, construct the new module. If the bytes are correct, if bytes are invalid, throw a new compile error. That's it. Let's see what are exports, imports, and custom sections now. So exports tells us what section of module is exposed to our JS API, like methods, variables, etc. In layman terms, I can explain it to you in the concept of JavaScript. So whenever you're creating a module, JavaScript module, and you want to export certain functions from that module, you just add export behind it, and only those functions are available whenever you are importing that module using the imports command. In similar way, assembly script as well gives you a functionality where you can export certain functions to the JS API. To export a particular function, you just need to simply add export behind it. Let's create a new function called subtract. And I will not add export behind it. And let's see whether it is available inside the export section or not. So I'll compile this file up and I'll try to fetch it. So inside this module, I have two exports, but subtract is not a part of it. Simple reason being, I did not add export behind it. Let's add export behind it and see if we are able to access it or not. Loading the WASM file again. And this time we have 3 exports and we have subtract as well. Let's try to call it as well. We have instance here, temp1.exports.subtract, and I'll pass in 10 and 90, and I receive -80. It works fine. So what is exports? If you want to expose something that is present inside assembly script or any language you want to use, and you want JS API to access it, you just need to export it, and that would be available as part of module exports object. Let's see what is imports in the next section. So imports tells us what section of WebAssembly module needs to be provided by JS API during module instantiation. The statement might sound complex, but let me explain it with the context of a TypeScript web app. Let's suppose we are creating a React TypeScript project, and for some reason we want to use jQuery inside it, and we imported jQuery using script tag inside the index.html file. So currently our React project has no knowledge of jQuery since it is injected during the runtime. Now if we try to use jQuery inside our TS React code, it will throw a compilation error, which is valid because our project doesn't know what is this jQuery variable, but it does exist during the runtime and we want to access it as well. So there is a situation here. We want to use a variable that is not part of our project but is injected later during the runtime. In order to resolve this, TypeScript has provided us with a declare keyword where we simply declare jQuery as declare const jQuery and then use it anywhere in our React project. So this is the same concept that imports follow. We can inject code to a WASM file during instantiation, and that can be called by the code present inside the WASM file. Since assembly script is similar to TypeScript, we have a declare keyword here as well, which tells us assembly script that a kind exists and it can be provided by the JS API as an import. So let's see import in action. What I'll do is that I'll create a function here, multiply, and I'll return its multiplication. I'll also export it, but let me tweak it a bit. I'll create a function using declare keyword just as in TypeScript, and I'll create a function called imported multiply, and it'll take in 2 arguments, again b i32, and it'll return i32. And instead of multiplying manually, I'll call this import multiply function and provide it arguments. So you see, imported multiply is declared. It does not exist inside our code. It is not part of our code, but it should be injected during the runtime so that it is accessible to the multiply function and it can call it. Otherwise it will throw an error. So let's export it as well so that it is a part of imports object. Let's compile this file and see what we get. So I'll load the WASM file, and now we have an entry inside the imports object where it says a kind function is required, which should be a part of module called index, and its name should be imported multiply. Now if we try to instantiate it, we will get an error, and the error says that imports argument must be present and must be an object. So let's try to import it. So inside main.js, so let's start off by importing an empty object. Let's see what happens. So I provide an empty object and I'm compiling it, and I load it again, and it throws a different error now. It says that yeah, something was imported, an empty object, but what I need is a module called index, which should have a function and its index is 0. So if I go to a wasm file, there is a function declared here which is part of index module. Its name is imported multiply, right? And it takes into arguments and returns a particular thing, and its index is 0, as you can see here. So part of index module simply means that I need to create an object called index here, and then I need to specify a function called imported multiply here, and then what it does is it takes in 2 arguments and returns their multiplication. So let's try to run this now and see if we are still getting an error or not. I'll load this file, and this time our instantiation was complete, and we have an add method here. We have imported multiply as well because we exported it. We have memory by default. We have multiply as well and subtract as well. Let's try to call multiply now. temp1 dot exports dot multiply, and we pass in 12 and 12 and returns us 144, which is correct. Just to verify whether multiply is using our particular declared method here or not, I'll do division here and see what we get, and we need not recompile our wasm file. So we got the instance again, and temp1 dot exports dot multiply, this line 12 and 12, and we got 1. So this is the power of imports. We can import or inject our own piece of code inside a wasm file, and then the code in which a wasm file is written, it can access it and call it on its own. This is what imports is. Let's see what is custom sections in the next section. So in order to understand custom sections, let's first try to understand what are sections itself. So a binary encoding of a WebAssembly module is a combination of different sections. We have a total of 13 sections. We will be taking an in-depth look at all the sections in later videos, but for now let's just see our WebAssembly text format file, which is also called a WAT file, to understand it a bit. I have this code written in assembly script, and when I compile it to a wasm file, a release.wat file is also created, which is a WebAssembly text format file. Here you can see we have module written here, and these types, imports, memory, exports are nothing but different sections. We have 13 sections, as I said before. This is a list of those sections, and you can compare it with the WAT file that we have now. As for the custom section, it's a bit different from all these sections. A custom section is actually not part of a WebAssembly module instance that we create. It is usually used for debugging purposes and adding additional information during the compilation process. We can access custom sections using the JS API. So let's see it in action. So since custom sections are actually used for debugging and adding additional information during the compilation process, assembly script has provided us with a transform module. So transform module actually has a hook called after compile, using which we can add custom sections to a particular module. This particular uint data array is actually a representation of hello string, and I'm adding a custom section with key as some key and data as the byte array of hello string. And then if we want to add this particular custom section, I need to run a specific command. Let me clear the console. I need to run a command which says I need to create a wasm file using the debug mode, and also transform it and provide the path to the file, which is assembly/transform.js. So when I run this particular command, if I go to the WAT file, you see towards the end we have a custom section declared here, where its size is 5 because hello is of 5 length, and the key is some key. Now if I try to access it using our code, let me try that. So we have a module here called module 2, and if I want to, and you can see it's not part of our code anywhere, and if I want to access this particular custom section, what I can simply do is WebAssembly dot module dot custom sections, and then I need to pass in the module here, which is module 2, and then I can provide the key. I think it was some key. So I received an array that has an array buffer, and if I want to decode it, I can simply do new text decoder dot decode, and it is some key since it's an array. Module 2. So now you can see I received the hello as well. So this is what custom sections are. Since it's part of the module, I thought of explaining it to you, but mostly it's part of the sections that we have inside the WebAssembly module, and we'll be discussing it in the next videos. So in this video, we saw how compilation works under the hood. We understood exports, imports, and custom sections. In the next video, we'll be discussing about memory and kind. See you later, guys.